Maybe my internet is not that fast. Okay, it is still loading right now. Is it visible now, my screen?
No, sir.
Okay, what is happening? I don't know. Let me stop the sharing and then I will again share. Okay. Is it visible
Yes, sir.
now?
Yes.
Shukr. Finally. Okay. So we did Coulomb's law, right?
Yes.
And we did 2 questions based on Coulomb's law, right?
Yes, sir.
So do you have any question or any doubt regarding?
No, sir. No.
Fine. Right. So next is yes. So what will happen if we place a dielectric medium? So in earlier classes, I said that, okay, right. So in earlier classes, I said that you have 2 charges, right?
Yes.
And these are in air or in vacuum, right? But in reality or in a general scenario, you don't have air or vacuum, right?
Yes.
So there are mediums, right? So
Yes.
what will happen if these charges are in a medium with dielectric constant, let's say K, right?
Yes.
So when these are in air, what was the Coulomb force?
F is equals to K Q1 Q2 by R square.
Right. Now K was what? This was 1 by 4
4 pi epsilon naught.
Q1 Q2 by R square. And this epsilon naught signifies that it is in the air, right?
Yes.
Now, when we place it in a
It in the
medium,
medium. Yes.
right? So the Coulomb force will change, right? So the Coulomb force will be now, if we place it in a medium, and the separation is same, and this is placed in some, let's say, medium. Okay.
Yes.
So the Coulomb force will now be 1 by 4 epsilon, right?
Yes. Q1 Q2 by R square.
And where this epsilon is what?
In medium.
Yes. So this is the permittivity of a medium, right?
Yes, sir.
So what I will do from the next class is that I will do more questions and I will skip the theory part, right? Because you are already familiar with the theories, right?
Yes, sir.
So it would be beneficial that we solve more problems, right? So
Problem.
we practice more questions, right?
Okay. Yes.
So that would be nice, na?
Yes, sir.
Or do you want me to focus on theory part and then the
Sir, now.
right? So you seem to be have a grasp of the theories, right? So I will from the next classes I will prepare more questions, right?
Okay.
So let's just pair with some theories for this class, okay? And from Saturday, right? From Saturday, I will prepare more questions. Okay.
Okay, sir. Okay.
So this is permittivity of the medium, right? Now, this permittivity is how this permittivity is dependent upon the dielectric constant, right? So we can write this permittivity as some K and epsilon naught, right?
Yes.
where this K is what?
Constant.
Yes. So these are all constant, right? So this is called the dielectric constant, right?
Yes, sir.
Dielectric constant. And when you keep this epsilon naught here, so this will be what? Epsilon by epsilon naught will be key. And this is also called ER, right? So this is
Yes.
what? So this is what? Relative permittivity.
Permittivity.
Yes. So this is relative permittivity, right? Relative permittivity. Right. So this is equals to what? So your ER is equals to what? K. Okay. K, whatever, however you write. Okay. Understood.
Yes.
Now, how this is related with the air, right? So in medium, hello.
Yes, sir.
Yes. So in medium, it was what?
Um.
The force was
F.
1 by 4 pi epsilon and Q1,
Q2
Q2
by R.
by R square. Right. This was in the medium. Right. Now we already know the relation between E and K. So this we can write as what? Q1, Q2 and 1 upon 4 pi K epsilon naught. Right. And then R square.
R square.
Right.
Yes.
So we already know that. Let's just,
Epsilon naught.
yes, Ke epsilon naught, right? So E,
Okay. Okay. Yes. K. K.
so epsilon can be written as Ke epsilon, right?
Yes, sir. Yes. Yes.
So yes, so where was I? So Q1, Q2 by, and this is what? 4 pi epsilon naught and R square, right? And then 1 by K, right?
K. Yes.
And now we can write this. So this was what? This force was equivalent to. So this was F air, right?
Yes, sir.
And divided by K, right? So this was F medium.
Okay.
Understood?
Yes, sir.
Now let's say, so this K is in the division, right? So
Yes.
let's say this is 4 or 5 or something. And this K is more than 1. Okay.
Yes. Yes.
So F medium will always be less than equals to what? Air, right?
Yes.
Understood, na? Because there is a division in the denominator. And if this division was less than K, then this would have been greater than F here. But this K is, so this dielectric constant K is greater than equals to 1, right?
Yes.
So if this K is greater than equals to 1, which implies that F medium is less than equals to F air.
F.
Okay.
Yes.
So there are some values that one should remember. And what are the values for K? So for air, it is 1, right?
Yes.
And for a conductor, it is what? Infinity, right?
Okay.
And for water, it is 80. Right, just remember these values. This can be helpful sometime.
Okay,
Okay.
sir. Okay.
Now let us do one question based on this dielectric constant. Okay.
Yes, sir.
So the one question that was somehow deleted in the previous class. Okay.
Okay, sir.
So yes, so this was the question. So charges, two charges, Q1, Q2. Okay.
Yes.
Q1, Q2 are placed at a separation R, repel each other with the force F. So these are in the air, right?
Yes.
And calculate the force between them when magnitude of both are. So this is the old question. Where is the question writer? Okay, so did I? Okay, so where did the question go? Okay, so this was the question. I should rub this part.
Okay.
So the force between them remains the same, right?
Okay.
So two charges Q1, Q2, when placed at a separation R in air, repel each other with force F, right? So they are repelling. So what can you say about these charges if they are repelling each other? Hmm?
Um.
If they are repelling each other, what does it mean?
They're attracting.
They are repelling each other. Okay, my question is that they are repelling each other. So what can you say about the charges, right? So I am asking about they are repelling already.
Okay.
So they must have the same sign, right? Either they are positive,
Okay. Okay. Yes. Yes. Yes.
or either they are negative, right?
Yes. Yes.
So that is why they are repelling, right?
Okay.
Right, na?
Yes.
Okay. So yes. So we know the charges Q1, Q2, the separation R, and the force F. So let's just write this one first. Okay. So F is what? A Q1, Q2 by R square. Right.
Yes.
This is given. Right.
Yes.
Now the second part is that at what separation? So they are asking about which part?
The separation.
Right. So this part, right? Separation is this.
R
So,
square.
yes. So R dash they are asking, or let's say, so this was the first part, that this was the separation, and these were the charges and the force was F, right? So this case. Now we have some uh, some separation R dash, right? And the
Yes.
charges are same, right? Charges are same, but the separation has changed.
Okay.
And the dielectric constant is they are placed in a medium, right? So they are placed in a medium. So this is placed in some medium. Okay.
Okay.
So, okay. So what will be the force when your dielectric constant is 3? So, sorry, what was this? Did I? Hello?
Yes, sir.
Okay, I heard some weird sound, weird noise. Okay. So, so force will be what? And they are saying that the force between them remains the same, right? So let's say that this is F prime, okay, and these are placed in a dielectric medium. So 4 pi and
Oops.
3, right?
Okay. Okay.
3 epsilon naught, right? So I should write here. 1 by 4 pi epsilon,
Okay.
right?
Yes.
So 1 by 4, 3 pi epsilon naught, charges are same, right?
Yes.
And we don't know about the separation, right?
Yes.
But in the question, what do we know? We know that the forces between them remains the same, right? So your F, and what can you say about F and F prime?
There are different forces.
No, so just see the question. They are asking that the separation is changed and they are placed in a dielectric constant 3, but the key idea or the key information that they are giving is that the force between
Remains.
them remains the same, right? So
Yes.
whatever the force was and whatever your F prime is, these are what?
It remains the same.
Yes. So F prime is what? F, right?
Okay, yes.
So this is the information, right?
Yes.
Now we will use this information. And what are the unknowns here? Q1, Q2, R square, we know. Q1, Q2, and we know. So R prime is the unknown, right?
Yes.
So we will calculate this R prime. So F prime is what? 1 by 4 pi 3 epsilon naught Q1, Q2 by R prime square, right?
Yes, sir.
And this is equals to Q1, Q2 by what? 4 pi epsilon naught R square, right?
Yes, sir.
So this is what according to question, right? This one.
Yes.
So this cancels what? And this cancels, this cancels. What is remaining? 1 by 3 R prime square.
Yes.
R prime square is equals to what? 1 by R square,
R
right?
square. Yes.
So this will come here. So R square is what? 3R prime square, right?
Yes.
So we will take the square root, right? So, or we should keep it or take it here, right? So this will be what? R square by 3 will be R prime square, right? Right.
Yes, sir.
So this will be what? So this will be what? So R prime will be, so let's take the square root both sides, right?
Yes.
So taking square root on both sides. Right. So
Yes.
this will be what? So this will be what? R by root 3. Right. So this
3.
is the answer. So this will be the answer. Right.
Yes, sir.
So this is the new separation. Okay.
Yes.
Okay. So are you well? Are you all right?
No, sir. I just have a cold.
Okay. Did you drink the cold drink?
No, sir. I am still fasting right now.
No, no, no. I said during iftar you had a cold
Yes,
drink.
sir. It's actually the season is changing right now.
Okay, okay. So
Sometimes it's summer, sometimes it's cold. That's
yes,
it.
yes. So that's a seasonal. Okay.
Yes.
So increase your or boost your immunity, right?
Yes, sir.
Okay. So now this Coulomb's law part is completed, right? Now I talked here that what will be the charge when you have only one charge with one charge. So there were two charges, right?
Yes.
So there was one charge and this was the other charge, and we were calculating the force on this charge due to this charge, right?
Yes. Yes.
Now, what will happen if you have multiple charges? So you have n point charges. So then what will happen to a single charge? What will be the force of repulsion or attraction when you have system of n point charges? Okay.
Okay. Okay.
Okay. So super prism
Yes.
position, right? So this is used when you have force on a charged particle due to system of endpoint charges. Right.
Yes, sir.
So the superposition principle solves this problem. Okay. So
Yes.
let's say you have 1 point charge here, right? So let's say you have a 1 point charge here, Q, right? Oh, so this is not. Okay. Which one is this? Yes, so this one. So you have a Q charge, right? And you have, let's say, this one, multiple charges, right? Qn charge. So this will act on this one, right?
Yes.
So this will be what? F1.
Okay.
F1. So let's say this charge is also acting. So this will be what?
F2.
F2, right?
Yes.
And this will be what?
F3.
F3, right? So and so on, right? So
F1.
now, right. So last is what? Fn dash 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 f, right? So the superposition principle states that when you have system of endpoint charges, so the charges on this test, so this is the test charge. So the force on this test charge or force on this charge will be what? So the force between the, so on force on the test charge due to n point charges will follow superposition principle. And so one should ask, what is a superposition principle, right?
Yes.
So superposition principle state that
The total force on any charge due to a number of other charges is the vector sum.
yes, so vector sum, right?
Yes.
Not the algebraic sum.
Yes.
Algebraic sum means that when you add 1 plus 2 plus 3, that will be 6, right?
Yes, sir.
But vector sum means that we have 1 iota plus 2j plus 3k. So you can't add I plus j with some other k, right?
Yes.
Your iota or your I, not iota, your I cap will only be added with the I cap and your j cap will only be added with j cap. So that is how the vector sum works, right?
Yes, sir.
But algebraically you can write, you can add 1 plus 2 plus 3 like that. But the force is the force on this test charge due to the system of n charges will be added like vectors, right? So this is about the superposition principle, right? So as you were telling, that is why I am saying that I will skip the theory part,
Yes.
and I will more focus on the questions from the next classes onwards, right?
Yes, sir.
Right now, because it will save your time.
Yes, that's fine.
So superposition principle, yes. So it states that force on the test charge will be the vector sum of forces
Individual.
due to individual charges, right?
Yes, sir.
Now, so there is one important quantity or term is embedded in here, right? So vector, right?
Yes.
So we should learn vector first, right? So let me write the theory here first, that your force will be what? Your force will be vector sum of,
Plus F2 plus F3 plus F left N.
right?
Yes.
So this is the superposition principle, right? So let us just study about the vectors first. Okay. Okay. So again, what is a vector quantity, right?
Which has both magnitude and direction.
So vector has what? Magnitude
And direction.
and direction, right? So let's say you have a vector A. Okay. So you can, so this will have two components, right?
Yes.
So this will have a magnitude and this will have a direction, right? So this is the unit vector. Okay. And unit vector signifies, so unit signifies what? 1, right?
Yes.
So unit signifies what? 1,
One.
which means that its magnitude will be what?
One.
Its magnitude will be 1, right? And it signifies the direction, right?
Yes.
So it signifies the direction. So this part is the direction part, and this part is the magnitude part, right?
Yes, sir.
So that is how you have a vector which have a magnitude and a direction, right?
Yes.
Now there is so before I go into other topics, let's just, so there are some universal unit vectors, right? Which means
Yes.
that, which means that, so there are, so if you have a three-dimensional system, right? If you have a 3D geometry, and this is X and this is Y and this is Z, right?
Yes.
Okay. So universal, so there are three universal vectors, I, J,
J and
and
K.
K. So I is defined like it is a one unit direction in the X direction.
X. Yes.
So when you move one unit in the X direction, that is your I hat, right?
Yes.
And when you move one unit in J direction, right, this will be
Yes.
what? J hat. And when you move one unit in Z
K.
direction,
Z.
so that will be what? K hat, right?
Yes.
So these are called the unit vectors, IJK, universal unit vectors. Okay.
Yes.
And as they are unit vectors, right? So
Yes.
what will be their magnitude?
I.
What will be their magnitude?
One.
Yes, right. So these are called universal unit vectors, right?
Yes.
And you represent vectors in the combination of these vectors, right?
Yes.
So you can write any vector. You can write any vector, let's say A, okay, as a combination of these unit vectors. Okay,
Yes.
so A, Z, K. Okay,
Yes.
and this AX signifies X component, right? This AY signifies Y component, and this Z signifies Z
Z.
component, right?
Yes, sir.
So if I write any vector, let's say if I write any vector like this, so 3i plus 4j plus 2k, right?
Yes.
So what do I mean? That this vector has moved 1, 2, 3, right? So,
Yes.
so this much it has moved in this direction, right?
Yes.
And 4j means what? 1, 2, 3,
Three.
4. This much in this direction, right? And 2k meaning what? It will be above or in the outward direction, right?
Yes, sir.
So I can't draw this line above the board or above the plane, right? So let's just assume that here, let's just assume that from here it is what?
Two.
2k. So 1, 1 and 2, right? So let's take the image. So 1 and 2. So this point is what? 3i plus 4j plus 2k, right?
Okay.
So this vector.
Yes.
Understood? So that is how you represent a vector in Cartesian form. Understood?
Yes, sir. Understood.
Okay. So we know already how can we represent a vector in Cartesian form, right?
Yes, sir.
Now, so we already know that vector has two parts, the magnitude, right?
Yes.
And the direction. Okay.
That. Yes.
So you are given a vector, given a vector 3i plus 4j plus
Yes.
2k, right? So we have to find the magnitude of this vector. Okay. So the magnitude of this vector in the Cartesian form will be defined like this. So this will be what? 3 square, 4 square, and 2 square. Okay. So let me write it the theory first. Okay. So you had this vector, right?
Yes.
So the magnitude of this vector will be what?
9.
Ax square plus ay square plus az square. Okay. For this
Yes.
vector. Okay. So this is how define the magnitude of the vector in the Cartesian form. Okay.
Okay.
So similarly, we calculated. So this was the vector, right? So your ax was what? Ax was 3, ay was what? 4, and
Two.
az was 2, right?
Two. Yes.
Right, na? So
Yes.
we calculated the magnitude ax square, ay square, az square. Okay. So this will be what? So this
9
is 9
plus
plus
16.
16 plus
4.
4, right?
29.
So yes, so this will be what?
220.
Huh?
229.
29.
Yes.
Yes, so 9, 6, 25, 4, 29, right? So this is the magnitude. Okay.
Okay.
And if I ask you what will be the unit vector, so
Um.
how will you calculate the unit vector?
Um.
So remember what should we remember? Remember what should we remember?
Okay.
That vector has two components, right? So magnitude, right?
And
And direction, or this is the unit vector. Okay. So we can calculate this unit vector by dividing this vector with its magnitude, right?
yes.
So this will be the unit vector. Okay.
Okay.
Now what was your vector? Your vector was
29.
your vector was 3i plus
Oh,
4j
4J plus 2K.
2k, right? And magnitude is what? 29, 220.
Root 20.
So if I ask what will be the unit vector, you can simply say that this will be what?
Divide.
A by A magnitude. So
Yeah,
this will be,
3i plus 4j plus
huh?
2 divided by root 29.
Yes, right, right. So 3i plus 4j plus 2k divided by root 29. So let's just write it separately. So this will be what? So this will be what? 3 iota by, not I, iota, I. Right. So
Plus
4 by
4j divided by 29.
and 2 by, right.
Divided by 2j. Yes.
So this is the unit vector. Okay. So
Okay.
if they give you the vector in the Cartesian form and they ask you what will be the unit vector, so you calculate the magnitude first and then divide with this vector. Okay.
Yes.
And so you already know about the dot product or the cross product, right?
Yes, sir.
Okay, so let's just do a quick revision on that and then we'll move on. Okay, so just quick revision. So dot product is what? So dot product A vector into B vector is what? A B cos theta, right? So
Yes.
this is the dot product and this is used to calculate this angle. Used to calculate the
And
angle between A and B, right?
yes.
And in general physics, where can you see the dot product? So when you calculate work done, so this is what the dot product, right?
Yes.
Okay, so this is used in physics theories, dot product, and you have also a cross product. Okay, so cross product, this you have already done, right? So that is why I didn't explain this much. Okay,
Yes.
so cross product is what? A cross B, and this is what? A B sine theta. But this is a cross product or a vector product, right?
Yes. Sir.
And this is a scalar product, right?
Okay.
So this is a vector product, so there should be a vector sign, so n hat. Okay. So that is how we define a cross product. Okay.
Yes.
And what is the use of this cross product? So when you calculate the torque, okay. So this is what your cross product, or when you when you calculate the linear angular momentum. So this is what your r cross p, or when you calculate what the linear velocity, which is what angular velocity cross r. So these are useful in these scenarios. Okay.
Okay, sir.
Now, as I was saying what? That when you have the Cartesian form, right? So when you have the Cartesian form of vectors, okay,
Yes.
so your life is easy. How? That let's say you have a vector A, which is 2i plus 3j plus 4k, right? And you have a vector B, which is 3i plus 2j plus 4k, right?
Yes.
So when you want to calculate the resultant of this vector, or when you want to calculate the addition of the vectors, so this is simple. Okay,
Okay, sir.
this is simple. How this is simple? Because you can simply add these two, right?
Yes.
So A plus B will be what? 2i plus 3j
3j plus 4k
and plus of
3i plus 2j plus 4k.
Right. So you
Yes.
can add 2i plus 3i. So this will be what?
5i
Plus 3j plus 2.
5j
This will be what? 5j, right? And
plus
4.
8k.
Right. So this is simple, right? So let's say
Yes.
this is R. But when you have the polar form, right?
Yes.
So that makes our life uh, a complicated, right? A complicated one. So what will be the addition of vectors in polar form? And in polar form, I mean that the vectors will be given not in the Cartesian form, just the vectors will be given and the angle between them will be given, right?
Yes.
So these three information will be given and you will have to calculate the addition of the vector or the resultant of the vectors, right? So
Yes.
let's just say that two forces two forces are acting like this. So this one and this one with 60 degree. So F1 magnitude is 2 Newton and F2 is what? 3 Newton, right?
Yes.
So this is not given in this form, right? In
Yes.
the Cartesian form. So now how will you solve this problem? So to solve this problem, we use mainly two methods, right?
Yes.
So in polar form, we use parallelogram's law or triangle's law for addition in polar form, right?
Yes.
So we will focus on this, right? And this is somehow equal to this one, right?
Okay.
So both this one gives the same result. So we will focus on parallelograms, right? So parallelogram law states that when you have two vectors, right? So this one is A and this one, let's say this one is B,
B
and they are making an angle theta, right? So angle between A, so
and B.
angle between A and B is theta, right? So
Yes.
firstly, how one should calculate the angle between two vectors? So we can't calculate the angle between vectors like this, right?
Yes.
So the vector has two parts, not the magnitude and direction one. So the geometrical representation of vectors has two parts, right? So this one is called the head of the vector, and this is the tail of the vector. Okay.
Okay.
So the to calculate the angle between vectors, we place the tail of one vector with the tail of the other vector, right?
Yes.
So we make them. There is a term called co-initial, right? So
Yes.
they are starting from the same point. So we make them co-initial, and that's when we calculate the angle between them, right?
Yes.
So where this okay, we cannot calculate like this. Okay.
Okay.
So first part is that we put the two tails of the vectors together, right?
Yes.
And then we extend from the head of the another vector, we extend another parallel vector, which is parallel to what? B. And it has the same magnitude as, same length as B. Okay. And then from the head of the second vector, we again draw a parallel vector, which has the same magnitude as, sorry about that. So this has the same magnitude as A. Okay.
Okay. Okay.
So this geometry is like what? So these four sides are
Parallel.
looking, yes, parallelogram, right?
Yes.
So that is why we call this a parallelogram law. Okay.
Okay, sir.
So the idea is that when you join the diagonals of this line,
It's
so
triangle.
huh?
It's triangle.
Not the triangle. So when you draw the diagonal of this parallelogram, okay. So this one is triangle, right? So
Yes.
when you draw the diagonal of this parallelogram, okay. So this will be the resultant of this vector. So this will be the R.
Okay.
So this is about the parallelograms. Okay.
Okay, sir.
And so what are two important points of vector? Magnitude and direction, right?
Yes, sir.
Now we will have to calculate the magnitude and direction of the vectors from this idea. Okay.
Okay.
So let's just draw the equivalent triangle, as you were saying, triangle, right? So
Yes.
let me quickly just explain what is the triangles law. So for parallelogram, we put both tails together, right?
Yes.
But for triangles, we put one head and one tail together. Okay. So this was A and this was B.
We.
And then we join the third side. So this is the resultant. Okay.
Yes.
So this was so this is the triangle. So right. But
Yes.
both give the same result. So we will focus only on this parallelogram. Right.
Okay, sir.
So what was our goal? Because vector has only two important parts, right?
Yes.
The magnitude and
And
direction, right?
direction. Yes.
So we will calculate the magnitude and direction from this idea. So let us just draw the equivalent triangle.
Okay.
So this was the equivalent triangle, right? Sorry. Okay.
Yes.
So this is R, this is A, and this is B, right?
Yes.
And what is the angle between A and B?
Theta.
Right. So theta. So this is what? Theta. Right.
Yes.
So this is theta, and you can draw two components of vector, right?
Yes, sir.
So if this is theta and this is, let's say, some A, right?
Yes.
So for the base one or for the horizontal component, so this will have a two component, right?
Yes, sir.
Or horizontal component, and this is what? Vertical component,
Vertical.
right?
Yes.
So this will be what? This horizontal component will be what? A cos theta. And this vertical component will be what? A sin theta.
A sin theta.
Right.
Yes.
Now from this triangle, okay. From this triangle, this is B. Okay, so this is B and this is theta. So this will be what?
The cos theta.
Right.
Yes.
And this will be what?
Sin theta.
Right.
Yes.
And let's just say the angle between one vector A and the resultant is alpha. Okay.
Yes.
Now let's just again draw some effective triangle, right? Two steps. So from here we come here and then we again draw a triangle, effective triangle. But this time we will draw a right angle triangle. Okay.
Okay.
Okay. So this is what? B sin theta.
And B cos theta.
And this is what? So this is this one. So this is what?
B A plus B cos theta.
Right now?
Yes, sir.
And this is R. Now, 10th geometry or 10th or 9th. Pythagoras, in which class we learned the Pythagoras theorem? Right?
In ninth.
9th. So we will use the 9th concept. Okay. So this is the hypotenuse, right?
Yes, hypotenuse
So hypotenuse is what?
is something like
Perpendicular square plus base square. Right? This will be.
yes.
So B I should write. Okay, B will be same. So I am writing this small. Okay.
Okay.
Right now?
Yes.
So what is our perpendicular? So this is our perpendicular. Okay.
Okay, sir.
So this is what? B sine theta square.
Square.
Okay. And what is B here? So this is
A
B.
plus B cos theta square.
So, right.
Yes, sir.
Now let's just solve this problem. So this is B square sine square theta. And this is what? A plus B whole square, right? So
Yes.
A square
Plus
plus
B square
B square and
cos square theta.
plus 2AB, right?
Yes.
So 2AB cos theta, right?
Yes, sir.
Now B square sine theta and B square cos square theta. Okay, so B square is common. So A square plus B square common sine square theta plus
Plus
cos
cos
square
theta
plus 2AB cos theta,
cos theta.
right?
Yes, sir.
So and again 9th or 10th trigonometry, we learned trigonometry in 10th, right? So this identity is called what? This is what?
Um
Sin square theta plus cos square theta.
Tan.
This is one, na? One, you remember?
Yes.
Sin square theta plus cos square theta is 1. Sec square theta minus tan square theta is 1. And what? Cosec square theta minus cot square theta is 1.
One. Yes.
So these were three trigonometric identities, remember?
Yes, sir. Yes.
So this is 1. And this will be what?
A
A
plus
square
A
plus
square plus B square plus 1.
so B square into 1 is B square, right?
Yes, yes, yes. Okay.
So 2AB.
2AB cos theta.
So this is the resultant magnitude of the resultant vector. Understood?
Yes. Yes.
So in parallelograms law, this is the magnitude and this is sometimes called the cosines law.
Okay, sir.
Understood?
Okay. Yes.
Now one part is remaining. We calculated the magnitude. What is the other part? The direction.
Direction.
Right, direction. Okay. So from this triangle only, we can calculate tan alpha. Okay. So tan theta is what? P by B, right?
Yes.
So this will be what? B sine theta,
B sine theta divided by A plus B cos theta.
right?
Yes.
So mission accomplished, right?
Yes.
We have calculated the resultant and the magnitude of the resultant, and we have calculated the direction of the,
Yes.
right?
Yes.
So this was about the parallelograms law. So let's just do one question based on that. As I was saying that let's say you have two forces acting on with some angles. Okay. So this is 60 degree, right? And this is 2 Newton and this is 3 Newton, right?
Okay.
So if I ask you what will be the resultant force, so this is F1. Okay.
Yes.
and this is F2.
F2.
So if I ask you, what is the resultant force? Okay. So this is exactly like the parallelogram's law, right?
Yes.
So we can directly calculate the magnitude and the angle. Okay.
Yes.
So what will be the magnitude? Right. So F will be what? F1 plus F2.
F2.
Right. So superposition principle. We are
Yes.
using superposition principle, right?
Yes.
And what will be the magnitude of F? We calculated, right?
Yes.
So this will be what?
2 square. Yes. 2 square plus 3 square.
Hmm?
Plus 60.
Right. So the magnitude was what? Because we are not dealing with the Cartesian form, right?
Yes, sir.
We are not dealing with the Cartesian form. So we are dealing with the polar form, right? So the magnitude is what? A square plus B square plus 2AB cos theta, right?
Okay.
So this is F1, right? So this is F2, right? So this will be what? So this will be F1 square plus F2
F2
square plus
plus
2F1 F2
F2
cos
theta.
60, right?
Yeah. 6.
Right. So this will be the answer, right?
Yes.
So F1, the magnitude of F1 is what? It is 2 square plus 3
Plus
square,
15 plus 2.
2, 2,
Yeah.
3,
23.
and
Cos
cos 60 is what?
is
Half, right?
1. Yes.
So this cancels. So we are left with what?
4 plus 9.
Yes. So 4 plus 9 plus
And
6,
2 is 6.
right? Na?
Yes.
So 9, 13 plus 6, 19, right?
Yes.
So this is the magnitude of the resultant force. Okay. And what will be the direction?
It will be division.
So this will be tan alpha
And alpha is equals to
b sine theta, right?
B.
By a plus b cos. So this was b cos theta, right?
Yes.
Oh, this was b sine theta or b. So this was b sine theta, right?
Yes, sir. Cos
Right.
theta. Yes.
So this will be what? So your b is what? 3, right?
Yes.
And let me write first. So your b is what? F2 sine
Sine theta.
sine 60, right?
Yes.
Upon F1 plus F2 cos 60, right?
Yes.
So this is 3 into sine 60 is what?
Half.
Root 3.
No.
Root 3 by 2. Yes.
Sine 60. Wait. I know this. Sine 60. Well.
It's okay. So sine is increasing one. So sine 0 is what? 0. What sound am I hearing? Okay. So sine 0 is 0. Right.
Yes, sir.
And And sine what? Sine 0 and then sine 30 is half. Then 1 by root 2. Now remember, root
Yes,
3
yes,
by, right?
yes,
And then what? 1. And then what? So this is how it goes, right? 0, 30 and 60. Oh, 45, 45, 60 and 90, right?
yes, sir.
So this is what? Root 3 by 2 by, now tell me what is cos 60. So F1 is 2 plus,
It's no,
it's,
it's one. No, no.
no, cos 60. You just reverse this. So when you reverse this will be what? 1 root 3 by 2, 1 by root 2, 1 by 2, 0. So these are cos values. These
Okay.
are sine values, right? So sine
Yes.
30 is root 3 by 2, right?
But it's okay, okay, okay.
So cos 60 is what? We calculated, na? Cos 60 was half, right?
Yes,
So half, right?
yes,
Now we will solve this. Okay, so this is 3 root 3 by 2, right? And this is what? 2 plus 3 by 2. So we should take the LCM, right?
yes, sir.
So this will be what? 3 root 3 by 2
Five.
by 4 plus 3 by 2, right? So this one guy
Five.
goes
Yes,
away, right?
yes,
So what we are left with? 3 root 3 by 7, right?
yes, sir.
So this is the angle. So what will be the final angle? So alpha will be what? Alpha will be tan inverse, right? 3 root
Yes.
3
Three
by.
root seven.
So this is the direction,
Okay, sir.
right? Understood.
Yes, sir.
Now, so as I've said earlier, that there can be three cases for the addition of vectors. So you understand this part, right?
Yes, sir. Sir, I actually have to go now.
Oh, again,
Yes, sir.
please. Uh, so this would be, your parents will only scold me, right? Because they will think that I am.
No, no,
Uh,
no. I actually told them to keep it at 2:30 p.m. here, meaning
okay,
it's 5
7.
over there in India. So
Okay,
that's my perfect time, but they are actually changing my timings again and again. So
because it happens that somehow I am not available at some time, and there are some other classes going on, so that is why.
yes,
Uh,
sir.
so that's,
Actually, I am actually busy right now. So I told them to keep it at 2:30 p.m. here,
but
but they're actually changing timings in maths and chemistry. Also, they were changing timings.
uh, but because you say 2:30 and at 5 p.m. IST, so I was in my college, so that's why I can't. I couldn't. I wouldn't have been able to take your classes. Okay.
Okay.
So that is how they change it to what? So can you come half an hour early for this, if that's okay with you?
So it's
If it is.
actually okay, but last time I told them 4 p.m., but they said you were breaking your fast.
Yes, so I will have just 5 minute 5 minute break, and then I'll come.
Okay, okay, fine then,
So if
fine.
it is okay with you, if you don't have any problem, or please, because we will have to finish the syllabus, right?
Yes,